Welcome back to Incremental, the continuous improvement podcast. This is our concepts edition for the week. I'm Devin Bedoni.
And I'm Uriel and
And we just wanted to mention we've gotten a lot of benefit from other podcasts, specifically the Business of Machining podcast and the Within Tolerance podcast, as well as the machinist community as a whole. And a big motivation for us doing this is wanting to contribute. We certainly get value out of these conversations, but we had the conversations before just on the phone.
Like the conversation between you and I.
Yeah, and it's a lot of time out of our week to make this happen, but kind of where that's going is it really makes us appreciate all the more the time that those folks have put in over the years and contributed.
Many years. I listened to the Business of Machining for, I don't know, probably 2 or 3 years, 4 years before buying a CNC. And it was a big part of kind of why I got into it and making it more accessible and approachable. Listening to all the guests build a business on Within Tolerance also kind of really helped me launch this business. And just getting into it
exactly
every week for us and coordinating that and all that definitely, I feel like made us both realize.
Yeah, so we just wanted to send a big thanks out to John and Dylan for making very niche topics more accessible and stimulating kind of the general conversation and sense of community. And we hope that this can be our little contribution to that larger conversation.
Definitely. And getting back to
what we do,
our normal routine here. Quote for the week: delaying decisions can make better cars faster. Holding less inventory can lead to more reliable on-time delivery. From the Second Toyota Paradox.
Yeah. I feel like there's two, obviously there's two, it sort of like comes across as one thought, but there's two very distinct concepts here.
Yeah, I think there's sort of like two paradoxes here.
Yeah.
One is about the development phase and one is about sort of the delivery phase.
Yeah. And it's actually interesting. This just jogged me of a quote from the I Ching that someone sent me the other day about after listening to the podcast.
Oh, yeah.
It's funny because, hi, Han. He happens to be in Europe right now, so it came in from this like random number, and I was like, who is sending me like I Ching quotes? But it was kind of all about like not changing too fast, like waiting till it's ready, waiting till the time is right. I could read the whole thing, but it's long. But I think it's interesting, like in the lean mentality being like, we got to improve, we got to change, we got to do all this stuff. And I think sometimes it is good, or it's important to remember the first part of this quote of delaying decisions until you've really worked things through.
I think there's a big reason we named the podcast Incremental, because like the R&D process, you are sort of trying to defer all decisions and not put labor or design time into executing on aspects that may be improved by learning on other parts, right? So like, can we tape some cardboard to the wall and learn a lot before investing an hour and $7 in plywood for a thing on the wall?
Yeah.
Because all in, you'll have a better result for cheaper, faster, but it feels slower to begin with. The reason this was sort of top of mind for me is we wanted to move our mill, spin it around. I think I've mentioned a few times on this podcast, it's facing the wrong way in our shop, and so you end up walking around it.
Yeah.
And so for a while, I've wanted to rotate it around. We borrowed some casters from you to do that, or some skates for the machine. And before doing it, Sam was kind of like, I know you're very convinced that this is a good idea, but like, I think we should do an A3, which is all about.
Huzzah.
Exactly. That's a big win. And so we sat down and did it, and it was really, really interesting. To begin with, the problem statement was, I forget exactly what it started off as, but basically let's spin, the mill is in the wrong position. And it's like, well, that's not really the problem. The problem is more about
like transport distance and walking. And
And so we kind of had bad orientation of the mill. But then yesterday we continued working on the A3, and Sam pointed out that the problem we had then stated as of yesterday was also kind of more a cause than it was, more like a symptom than it was a cause. And so our newest one, and unfortunately I don't have it in front of me, but it's basically unnecessary time going to the mill, unnecessary time taken to travel to the mill. And the reason we changed it is because it turns out that there's actually a lot of like rotating the mill is one small part, and it touches on a few aspects. One is, so our two problems that we're trying to solve, it turns out, one is unnecessary time traveling to the mill, and then the total time, like then you define, so you state the problem, then you define the targets and like current state, future state, and the gap, all in quantifiable numbers. And so what we came up with for current state for our two measurable items are time taken to go to the mill, but then also number of unnecessary trips taken to the mill. Because what we realized is it's not only walking around the mill a bunch, it's also, we then said, well, why are we walking to begin with to go over there? And so one is sort of not being confident, not having good standards on how the mill is left in terms of what's needed for the next setup. So sometimes we'll set it up immediately. Sometimes we'll get halfway through that setup and then be like, well, I'm in the middle of something else, so I'll just come back with 10 minutes left or 5 minutes left and sort of like reload the stock and do all that. And so because of that lack of standardization, then you start walking over to the mill to see like, oh, how many minutes does it have left? Or you're about to leave for lunch and you go like, oh, well, let me go check on it to see, because if it only has a few left, maybe I'll just wait and do a changeover and then take lunch, right? And so then we realize there's a lack of visibility into the, like where the mill is in its process.
It's more about state visibility, not about actual position.
Yeah, the position, what we've sort of decided is the position exacerbates the problem in that you're walking further to go to it. And then the other thing is because it's turned around, you can't see the front of the machine, so you can't see the indicator lights. Obviously putting a an and-on light on the machine, which is just like visible from all directions, would help. But then we started looking ahead a little bit, and we're contemplating moving the assembly station and the shipping station up into the loft, which would suddenly make it out of sight again. And so then it's sort of a question of, do we put lights upstairs and downstairs? Do we put, one of the things we're looking at is like, I'm into MMA and like doing jujitsu. You have like a 5-minute round and you have a clock and then it will beep when you have a minute left. So kind of like, well, that would be kind of ideal if it would beep and show you in the, like anywhere in the shop, you could glance up and see how much time was remaining on that product, or sorry, on that like whatever cycle we're making. But suddenly, instead of just it being about like flipping the mill around, suddenly rotating the mill is a very small piece of a much bigger, more interesting problem and kind of problem space with a lot more creative options. Which was very interesting. And so it took us, I would say total time we probably have into doing the A3 is maybe a little over an hour. And I have to say, sitting there feels like such a waste of time in a funny way, like in a sort of immediate way. Like yesterday, Sam was like, hey, should we finish up the A3? And I was like, man, like I have prototyping to do. I have like sales to do. There's so many other things to do, but I wouldn't, obviously it's still hard to squeeze in, but I wouldn't hesitate to take the time to rotate the mill because it feels like productive and like you're moving forward and you're taking steps and there's like sort of a bias toward action, which I know is spoken about as a positive. But I think focusing on the action, I don't know. It's been, every A3 we've done has been super interesting and really makes me think that like Sam and I both were kind of like, man, we should be doing a lot more A3s, both in this business, but also just in your life. I mean, I just feel like so many arguments with, or like disagreements with like a housemate or a partner or whatever. It's like you argue about these surface level things and never take the time to really say, okay, like what's causing this? What are the root causes? What is a real problem statement that sort of accounts for all the different aspects?
Right.
And like getting all that stuff right really clarifies your thinking. Uh-huh. And I think really stating things carefully, I think opens up the problem space and the solution space, because things like at one point we had a statement that's like missing, like we need better visibility into where the mill is in its cycle. Mm-hmm. But now if we start solving that problem, that's actually limiting the scope of like the possible solution set, because really I don't care about that. What I care about is arriving on, like, I forget our current statement, but it's more about...
It's not that you need to know where in the cycle it is. You just need to know when you need to arrive.
Basically, right.
Yeah.
And suddenly it's like, oh, now a clock on the wall could work with just putting magnets where the hand is when I need to go over, mm-hmm. which is way cheaper than,
right.
I don't know, lots of other options because we already have a clock. Not saying that that's the best solution here, but like,
yeah,
it's really interesting. Yeah. And we haven't done a thing. I mean,
right.
in terms of actual implementation, but I am, very clear to me that when we do, we'll have really good reasons behind it and we'll understand much more what we're doing, I think.
Yeah. It's kind of this interesting, delicate balance, right? Of between, having an unsolved hanging problem and making progress. Like on the one hand, there's like, and we talk about this often, and it's paradoxical, like the quote, slapping some cardboard on the wall and trying something is often beneficial. On the other hand, waiting and going through this whole process is often beneficial and will save you lots of time going down other roads. And like,
I think this starts
figuring out where and when is kind of the interesting challenge.
Definitely.
Because each have their sort of appropriate use case.
For sure. I think it is definitely a paradox and requires some thinking. Like, I don't think it's actually paradoxical, but it feels that way. Similar to like move fast and break things. And this is saying like move slow and contemplate things, right? Yeah. And if you do too much of each, like, I think the A3 process kind of focuses the direction of what piece of like what cardboard and what wall, right? I don't know. Yeah.
That's the wrong kind of tape.
Yeah. Like what is the actual problem we're trying to solve? Because then jumping into this, if we are interested in having a big timer on the wall that's just a countdown timer mm-hmm. that says like CNC 1, right? And mm-hmm. you can just look at it, know how much time. Maybe it beeps 3 minutes before. Maybe it beeps at a point that we can program into the CNC, into the G code, right? Mm-hmm. Just put an output that's like...
Yeah. One more thing to go with your... with your mist collector.
Yeah, exactly.
Mist collector went twice in a row.
it's time. And I think that's where you get into the cardboard, is instead of programming that whole thing, we'll probably make some versions that just use a clock or, that are more manual, more set up, but can test the functionality mm-hmm. without spending a lot of time and money.
So is the conclusion kind of that the mill doesn't need to move, probably?
No.
Like there's still benefits to moving it.
There's definitely benefits.
Yeah.
It is clear that it is not the problem.
Yeah. It's not the root cause.
It is not the root cause. Rotating the mill will save us time on every trip, both necessary and unnecessary. Uh-huh. And so it touches all trips.
Right.
The other thing is... sometimes like your shop gets stagnant in a funny way, and everything feels unmovable, and I don't think that's like a very creative.
Right, you're just kind of in a rut.
Yeah, you're like, well, that can't move because this, that can't move because this, and so I'm excited to just
I know
flip it around. Like, what would happen if everything in your shop was on air bearings and you could just like, move it half an inch and that wasn't a big deal? Right, like that. And so I think just seeing that thing spin and setting it back down might give us new ideas about the whole. I don't know. I think just as an attitude shift, it'll be good. Yeah. But also, I don't think it's a waste of time here.
Interesting. Cool. That was enlightening.
And anyone who wants to do A3, just look up a template on A3, look at it, read the titles, be confused, try to fill it in, realize you're doing it wrong. I mean, that's what we've been doing basically the last 2 weeks. Yeah. And every time we get a little better at it.
Yeah. Just for kicks, the first line of that quote from the I Ching, or I Ching, I'm not sure the correct pronunciation. Changing inspires confidence only after it is accomplished. It's kind of, I was like, I hadn't hit home the first time because I think I was in the middle of work and was like, who the hell is texting me
from Europe?
And just like skimmed it. But in this context, it's interesting to just kind of like place that sentence, like being midstream, kind of in limbo, not very helpful. But I think if it's directed by this process, it is beneficial.
Yeah, and I would say the secondary benefits, or maybe the primary benefits, probably the primary benefits now that I'm thinking about it, is investing in people. We are both getting better at problem solving, and then we are both going to be problem solving on every future problem for the company as long as we're involved. Yeah. Right? So like that's big. Yeah. And the mill is not a big problem. Right. So yeah, maybe that is the bigger benefit here. Is ideally if we could improve our percentage of time in our day allocated to solving root problems rather than surface problems, I feel like that would be a huge benefit to the company.
Yeah, when you say it that way. Yeah, for sure. Huh.
Anyway, moving on
up.
Hopefully.
Yeah, one can only hope.
I'm intrigued by your first entry here.
Minimize flow versus minimize cost of flow.
Yeah.
Yeah, I'm slowly, very slowly making my way through this Job Shop Lean book.
Yep.
I think everybody should. I mean, it's a good book. Okay. It's very dense and not like exciting the way it's written. But even if you are not a job shop, I would suggest reading it.
Is it limited to people who make physical things or not even? Or probably sections?
I think that's its primary focus.
Okay.
Yeah. But I do think you could apply the concepts more broadly.
So not having read it, I would guess that there's a lot of analysis tools that are very useful no matter what you're making. And then if you're a job shop, then the conclusions are kind of correct as well, or something like that.
Yeah, I think so. There's a lot of case studies and sort of examples.
Gotcha.
And it's like the more I get into it, his thing really is about blending lean with theory of constraints and then some other stuff that I hadn't even heard of.
Very cool.
Which is pretty cool. There was one interesting mention in the page I was reading last night about this guy from England in the early 1900s who apparently was one of Ono's inspirations.
Okay. Gerbrecht?
No, Woolard?
Huh.
Yeah, some whole book. I think he made, well, I don't know if he coined the term, but he wrote a paper in the 1920s that mentioned flow. So anyway, and a big part of this book is about distinguishing between assembly type operations versus more the manufacturing kind of operations that we were more involved in.
Okay.
Like, because most lean examples are for assembly lines.
I see what you're saying.
Which are not widely applicable necessarily.
Right. You assemble packages, but those are pretty basic.
Yeah, and you assemble a product.
Yeah.
But that's a very kind of a small percentage of what you do as a whole.
Yeah.
So I think that's a really important kind of fundamental distinction that the author is making. With this part, minimize flow versus minimize cost of flow, was like, it can be really easy to get super focused on trying to create this ultimate flow.
Mm-hmm.
And forget that the ultimate goal is not to have a flow. It's to make your thing in one hit, right?
Right.
Like the perfect production process, you put raw stock into something and you get a finished part out.
Right. You're not linking processes because it's one process.
Yeah.
I think this is where the distinction that took me a long time to wrap my head around with Shigeo Shingo, of distinguishing between process and operations, and that you should only refine processes. That you should start with refining your process before you refine the individual pieces of your process for exactly the same reason.
Yeah. And it's basically a different way of looking at that same context, or that same concept of being like, okay, so you have, this cool step and then this cool step, and you want to like put them closer, but can you remove a step?
Mm-hmm.
And he's putting that in terms of cost. Like, that has a cost. Like the cost of the flow that you are that you're proposing, the flow system that you're trying to implement, try and minimize that cost as much as possible.
Yeah, so easy to do. I mean, a real example that pops into my head is all the time on this podcast that we've talked about my tumbling.
Yeah.
When really it would be ideal if I didn't need to tumble at all.
Yeah.
And that is a real potential option.
Right.
And that might take more cycle time on the CNC, which feels like an absolute no-no, but both have a cost.
Mm-hmm.
And honestly, the added time on the CNC is probably a lower cost.
Yeah.
Especially if you have someone picking parts out of a tumbler for 5 minutes.
I would guess that if you really mapped it out, it's not so off the mark.
Yeah, I mean, if I financed a CNC, let's say it was $2,000 a month, just to make it convenient, and let's say I pay an employee $200 a day to be there, then yeah. Especially if you get overnight runs.
Right. Yeah, 100%. I've been reading this book, and as I mentioned a few weeks back, contemplating moving into a new space. Still in the negotiation phase for that. But this kind of leads into the next point I had here, was like, how do we lay out our new system? Mm-hmm. And similarly with tumbling, right now we like have a single tumbling unit that all machines feed to. Like, do we start to treat our whole shop as a cell where each machine kind of feeds a thing in sequence? Or do we treat each machine as a cell, or maybe a pair of machines as one cell and the other machines as individual cells? And do we like include tumbling, deburring, inspection at each machine? Or do we, make them all sequential? Because we're in this kind of weird middle ground where in a large factory, a shop our size probably would be an individual cell.
Considered a cell.
Yeah.
Absolutely.
For our purposes, a lot of our products do run on one machine.
Yeah.
A lot of the stuff we make. So we could sort of treat a single machine as a cell. And I don't know where we're going to go with this, really. Maybe some kind of hybrid, honestly.
Yeah, it's interesting because on one hand, like if you just imagine that the CNCs are completely portable, which they're not, but let's just say they are.
Yeah.
How would you behave? Like, would it be something you rearrange every new job you get? You're like, oh, let's do a row that is like, let's do a U cell that's like one CNC, an inspection station, a cleaning station, or an inspection station, I don't know, or tumbling, then inspection, then cleaning, then packing.
No, I don't think so. I don't think we would move the machines very much.
Yeah.
Like every once in a while, for job that goes across multiple machines, we might move them, but not really.
Yeah.
So that maybe
leads
to each machine being its own cell, sort of.
Yeah. And then the routing, interesting. That's pretty interesting to think about. I wonder if it would, and this probably not. This is A3. This is our A3 territory. I wonder if having a like when you put a new job on your job board,
yeah,
having a map of the shop and like explicitly drawing a flow map of that product, right? It goes like sawing this CNC, that CNC, over to tumbling. I don't know. I wonder if that would be informative. You'd end up with a bunch of these like
spaghetti maps.
Spaghetti map. I don't know if it would be a spaghetti map. It would be like an ideal.
Yeah. I think the thing is our process is actually fairly unified, so it's not very complicated.
Yeah.
We have occasionally parts go from lathe to mill, but for the most part, all of our parts, we work hard to have them run complete on a single machine and finish parts every cycle.
Yeah.
So our routings are pretty simple. It's just kind of like, do they get tumbled or not? Do they ship to anodize or not?
Do we laser them?
Do we laser engrave them? Yeah. It's all kind of that post stuff. So there's a pretty strong argument, honestly, to have, because we feed everything with a common saw, to have the saw feed a bunch of machines, and then all of those machines feed back into common processes, a common flow line of tumble, deburr, tumble, anodize, outsource for now, laser, which I sort of am leaning towards, and I think it's more scalable than having every time you add a machine, you add an inspection station, you add a suite of tumblers, you add, whatever the case may be, as our processes capabilities grow. I think it's more scalable and also kind of allows for distribution of labor more easily.
Yeah.
But it also creates more specialists instead of generalists, which is kind of another question in my mind of like, are we trying to create in our shop, are we trying to cultivate project owners? Or are we trying to cultivate process owners or operation owners? And both have benefits.
This is jogging my memory. I'm going to try to dig it up. There's a Shigeo Shingo book where he's at a plant and they have they have a line that is fed by they have two lines that are fed by one saw. And he comes back after recommending some improvements. They implement the improvements except for feeding two lines with one saw. And then he comes back and says, you need to get a second saw and feed each line.
Because it was a bottleneck, or just because?
Because in the overall math, it required one fewer employees. And so the cost of the saw was really much lower, and I'm forgetting exactly why.
Interesting.
Yeah, I'll try to dig it up. But let's think.
Probably because...
It's something to do with process synchronization, basically.
Yeah, because having two saws allowed one employee to just saw.
Instead of needing
multiple employees who were like multi-process people, and they would sometimes saw.
Here's what it was. They had which isn't necessarily applicable, but it's still interesting. They had a person at the beginning of process A, or line A and line B.
Yeah.
That got stuff from the saw and fed it into the beginning of the process.
Yeah.
And then there was some, once it started in the process, it could just continue.
Yeah.
And so by splitting off and having two saws, the saw could directly feed into the process. And so so instead of one person manning the saw and then two people pulling from that saw and walking it to their process and starting their process, they just moved those two people to the saw and freed up the saw operator to go do something else, which I thought was...
Yeah.
So actually, in your case, that could apply if someone had the time to... Right, if you had one saw, not that it does now because you don't have someone sawing full time, but you could theoretically have an auto saw that keeps up with tack time in each cell.
Sure.
And then that person manning that cell can just operate the saw and operate everything else.
Yeah.
Anyway.
Interesting. Yeah, that's a cool thing to think about. At the moment, sawing is such a light load,
right,
that I don't think we're nowhere near that.
Totally.
place.
It might apply to like tumblers and all these other things where having that it's an interesting point because specializing has its merits.
Yeah, it really does. I think the main benefits are more to do with like labor leveling, sort of.
What does that mean?
Like, there's a lot of tasks. If you make somebody a generalist, like, and we kind of gamed this out a little bit. We were like, okay, so what if we do kind of like, on With Intolerance a while ago, there was, I'm blanking on his name now, but he runs, he's one of the folks at Pro Shop.
Okay.
They ran a shop prior. They had this concept called bar to box, where the employee would like saw the material on the machine, deburr straight into the box, ready to ship. So we kind of gamed this out in our shop, and we're like, okay, should we get, is this a valid concept if we're making each machine a cell? Very quickly, it became clear that, like, I mean, there's very basic things, like if your hands are covered in coolant, you don't want to be packaging finished parts.
Right.
So that's a problem. So immediately you get this like nexus where you're like, okay, we should separate these two processes just from like a quality standpoint. And then there's also just like, okay, so it might take 10 minutes to go and print the shipping label, get everything taped up and out where it needs to be. That's time this operator's away from their machine. So if the goal is to keep a machine running, having one person do these two processes that could be parallelized instead, kind of like we were talking about last week, it doesn't make sense to have one person responsible for both of those.
Right. I guess I'm not at all saying that's incorrect.
Yeah.
A few thoughts. One, Eliyahu Goldratt, if you were alive, would remind us that the goal is profit.
Yes.
Not to keep the machine running, but
no.
If it is your bottleneck, then
the goal is throughput.
Isn't it profit?
Well, to have profit. I mean, the goal is profit, yes, but throughput.
But selling less at a higher margin is preferable to higher throughput.
Yeah.
Secondly, I think this is sort of. I wonder. This sort of gets into one of my questions. I wonder if it's worth thinking more about, like, that is a very logical and reasonable thing. Like, you don't want coolant on your wrapping paper. But I think walking away from the concept, and I'm sure you did a lot more thinking on it, and I know you're still thinking about it, but walking away from the concept because of that may be premature. Like, I wonder.
I'm not walking away from the concept as a whole.
Yeah.
Just kind of figuring out where the break points are.
Yeah. Like, what would happen if, I don't know, there was no coolant, or obviously that's not the answer here, or you pack every 10th part such that cleaning your hands is, like, I just wonder what it would do to the system. One of the things I wrote here that I've been thinking a lot about, and it sort of crystallized in a way for this week for me, is this idea that, like, focus in a company is about reducing WIP. Like, when people say you can't boil the ocean, or like for startups, or like for me or you, it's like, pursuing every industry simultaneously. Like, the issue becomes that you've invested time, which is money, into too many things that don't bear fruit. And so you can just, like, cash flow wise, it's a big problem. I just think about this, like, for me, I've been thinking about, like, launching new products. If I don't focus on actually getting a product to market, I could end up investing so many hours in R&D to launch 10 products at once that I just run out of money.
Yeah.
Right. And so focus becomes about reducing WIP, because WIP is tied up resources that are not shippable. Similarly, like bar to box, I just wonder, like, what are the upsides of having, like, at the end of every day, or really at the end of every half hour,
mm-hmm.
you have parts that can get shipped to a customer. And like, what is the cost of the extra moves in the shop, or the areas that are like sort of built for queues coming off of the machines, all these other things.
Yeah.
What are the, like, can you, like, you can suddenly flow value to your customer in a way. I mean, as we've discussed, a lot of customers aren't even equipped to accept that value.
Yeah.
And float onto their customers, because it's like, oh no, that production run is scheduled for next month anyway, so mm-hmm. we don't need it.
Yeah.
So I don't know. I mean, and then lastly, I guess on that topic of, like, bar to box, there is definitely a balance that I feel like I keep running up against, which is, like, theoretically the Toyota production system tells you one thing,
mm-hmm.
but in reality, in the current reality of my shop and business, it's not necessarily suitable. And I was just having this conversation with my brother about, like, queuing theory.
Mm-hmm.
If you have variability in your process, then you should have buffers.
Yeah.
Right. And I was talking about, like, if you see a buffer, it means there's waste. And he was like, no. Like, and I think both are true. No is, like, realistically, like, practically speaking,
yeah,
you're probably going to have buffers. But it's also very important to maintain the view of where your waste is as an organization.
Yeah.
I don't know. Anyway. It's
no,
really
100%.
Tough. Really tough to make the rubber meet the road appropriately for every stage.
Yeah, and coming back to scale too.
Right.
Like, at the end of the day, a lot of our decisions are going to be driven by how we can best utilize our labor. And so kind of what we came to, it's not a foregone conclusion yet, but in this topic, we were kind of like, okay, and we're already doing a little bit of this, not being like, okay, this one person is going to bar to box, but the goal will still be bar to box.
Right.
And it'll be like, okay, so maybe this one person handles all of the dirty processes. So, like, they take parts out of the machine, they do deburr, they rinse, they transfer them to a tray. They do QC, probably initial QC, like at the machine QC.
Yep.
And then maybe, like, every 10 parts, they move a tray to a queue, and maybe all 4 machines are feeding that queue, and then one person is responsible to be packaging things as they come off that queue.
Yeah.
And that person can track, where all these different things are going, and start to build the actual final packaging queue that's going to go out the door at the end of the day, hopefully.
Yeah.
And we've already started to implement this a little bit, not to this degree, but not waiting for a job to be done to start packaging.
Interesting.
So as, like, right now we're doing a part run that's 225 parts. So we're not going and packaging or, like, wrapping every single part as it comes off.
Yeah.
But, like, a tray at a time. So 25-ish parts.
Interesting.
Go and package so that they're ready to go in a box when everything is done. So I think there's, like, a huge middle ground as well, where you can like reap a lot of benefit without trying to get to this kind of, like, very strict interpretation of what a cell is, or, like, what one person does. And that way, the one person who's responsible for maybe all of the clean processes, we'll call them, they can just do that. They can be a specialist in that. And at our scale, because there's 4 machines feeding that position, they can stay relatively busy with that. Whatever little gaps are in their time can be filled with other small tasks. And then the people at the machines can focus on keeping the machines, throughput.
That makes a lot of sense. I'm reminded, and I can't remember what book it is.
Yeah.
Of this example I think it's Gemba Walks. That's what it is. At the beginning of the book, he basically says, like, he was involved in a lot of lean efforts, and he invested in a bike company and insisted that they weld the bike frames in the order that the orders were received. So it'd be like Model A, Model B, Model B, Model C, Model A, whatever the mix is.
Yeah.
Literally just in the order the orders were received. The company failed eventually for a lot of reasons. But one of his takeaways was that he sort of got a myopic focus on this concept of flow, but they were shipping bikes at the end of the day. They weren't shipping bikes in the order they were they weren't taking the bike, building it up, shipping it out as the next step.
Yeah.
And so there were inherent batches happening downstream. And so there was no, they would have saved they would have just saved time in changing which bikes they were changing the welding jigs. Now, was it worth putting in the time to make those changeovers fast? Yes. But that doesn't mean that you need to do everything anyways.
There should be
to your point.
Yeah.
There's some amount of where the rubber meets the road and what that looks like.
Yeah, there should be some rule that's well, I see a lot in this Job Shop Lean book and kind of all around. I see a lot of reference towards organizing around a day's production for batch processes.
Interesting.
And I think you could almost expand that to say organize your tact around batch size to a certain extent. That is a little bit of a slippery slope as batch sizes get large.
Right.
But I think there is some merit to be don't over constrain yourself by trying to create true single piece flow at every stage of the process. If the customer doesn't demand it, if the rest of the process isn't inherently built for it.
Yeah, and I mean, this keys into a question I have. Do we increase our paint batch size to save my time? Because my time is the bottleneck of the company at the moment. This is something I'm sort of pondering, right?
Yeah.
It goes against every symptom of the Toyota production system you kind of read about, right? Reduce your batch size, do all these things. But in those books, they're always saying this is not the point. The point is not small batch sizes. The point is not Kanban. The point is not efficiency of the process. The point is...
Of the operation, you mean? Or the processes?
Of the individual... Sorry, of the operation. The point isn't speed. Maybe that's how you get to the thing you do want. But, I mean, their focus is on systems thinking, or what they say the Toyota production system is about is systems thinking and scientific thinking. And that's it. And then if you apply those consistently, this is where they have ended up. But that's not to say that it is the right answer. I was just reading another book, Toyota Kata. And they're basically saying if you go to a Toyota plant at any given point, none of the Toyota plants have reached the ultimate goal of true single piece flow from top to bottom.
Yeah.
And they are fully aware of it and in fact sometimes increase their buffers, right?
Yeah.
Because of other reasons that are real.
I heard, I don't know if it's of any merit, but heard recently that, with all of the supply chain issues in the world and prior to that, Toyota specifically was increasing their buffers and their backlog to be able to weather that.
I mean, if your goal is to deliver value to your customer.
Yeah. And that they're moving more production in-house.
Then they're not going to, your customer doesn't care if you're but we have only 1 hour of inventory on hand. They're
cool.
I don't care. What I care about is value, the price and quality. And
is that 1 hour a Camry for me?
Yeah, exactly. So, I'm confused.
Well,
perpetually.
Yeah. Part of the paradox, I think. It's important to keep top of mind, I think.
Yeah, and maybe a different word for confused is the goal is to keep considering and the step of rationalize your production, which is super vague and but it is this, right? It's keep thinking about, does this make sense overall? Is this a good solution zoomed all the way out?
Right.
I think if the answer is no, something needs to change.
It's the perpetual conflict, right, between being active and present in a process versus becoming dogmatic.
Yeah.
And it's very easy to become dogmatic about lowering batch sizes and single piece flow. They're easy rules to follow.
Yes.
It's easy to just fall back and be like, this is the rule. We must make this happen. And it is super critical to always challenge dogma, no matter what.
Yeah. Right? I 100% agree. I mean, in a funny way, that's sort of what allowed Toyota to break out of the dogma of mass production.
Yeah.
Was questioning everything. And so to take what they've learned and then not question it is similarly faulty.
Yeah. Speaking of batching, one last little topic that was kind of an early thing or an interesting thing. It's a small concept, but was another thing from this book was batching early. So basically they were saying like, if you have to batch a process, like especially to outside vendors, do it as early in your process as possible, so that you don't need to batch midstream, like in an assembly process, for example. Like you don't have to interrupt a process that's a flow line.
I see what you're saying.
Try and batch before it gets into your flow line effectively, so that then things can flow. So don't do like a bunch of assembly and then have to send that thing out to post processing and then bring it back in to continue assembly. Try and have any outside processes or big batch processes like heat treat or whatever happen prior to the flow, so that it doesn't so that it can be like easily grouped, I think.
I wonder how that pairs with, and this might just be like, that is one way of looking at it and should be used sometimes.
Right.
And the other question to me immediately is sort of about like all the issues with batch work of like quality control, like shortening your feedback loops on quality control, and especially just final quality. Like anyone who's built anything knows that until you've fully assembled it and tested it, sometimes that's when you find a new problem you never knew could happen. And then if you have a lot of these things pre-built, you are going to be hopefully just able to modify them and fix the problem, but that's rework.
I think if you're assuming that you can't do the final QC till the end anyway, if it's done early, at least, and you do find it, let's see, how does this work out? And say at least there's less labor involved or labor invested.
Yeah, and I think both can be true. Like a great example is the bike example I was just talking about.
Yeah. Which
is like they should have batched their welding process because they were already batching their shipping process. And so it made no sense for them. Yeah. They should have batched as early as possible to meet the later batch. And that doesn't negate the quality control question, because your quality is on a complete bike frame, not on your total production for that day.
Right.
And so, yeah, maybe in thinking about it a little further, I guess both can be true.
I think so.
Yeah.
I'm trying to find the spot where they talked about it. I might not be successful though, so
yeah,
you should probably say something.
Well, the last point I have, and we're getting close to time here. Kind of a long episode. Again in Toyota Kata, they mention this idea of being stagnant. Like processes in a company have the tendency to start slipping, where it's like people get lazy, people forget about the reasons they're doing things a particular way, and so things start like backsliding. Yeah, very common. And then there's the alternate option of continuously improving everything all the time in a company. And then there's the last piece of this, which is if there's the possibility that other people are innovating in your space, then actually not improving is falling behind. And so suddenly improving everything all the time is kind of what you need to do to survive. Part of that is a time scale question of like, if you are looking like our career, let's say our career is 35 years, probably longer, 45, whatever it is.
Getting longer every year.
Yeah. Then it may be that in that time, innovation in your particular area won't put you out of business, even if you fall behind.
Mm-hmm.
But if you start zooming out and saying like, I want a company to survive 100 years, suddenly falling behind is a big problem.
Yeah.
And you can't just make up for that quickly. You can't come back from falling behind quickly. You need to continuously be looking at every single item in your company with an eye toward, even if we're not working on this now, let's become aware of the wastes. Let's think about critically where we need to fix things in the company, just like building in that attitude and that, not attitude, like practice, right? Like, Are we doing this every day? Are we building the skills in ourselves to see systems, to improve system,
Yeah.
I don't know. I just, like standing still is not an option, kind of, I guess.
Yeah.
If you're not improving, you're falling behind.
Yeah. Totally.
And with that, don't fall behind. Go improve your process. Thanks all for listening.
Yeah.
I think that's our episode for the week.
Indeed.
See you all again Friday. You can find me at austere_MFG. Manufacturing.
I
always get confused.
Yours is manufacturing. Mine
Yours
is MFG.
There we go. Austere_manufacturing.
You can find me at lichen_MFG.
And the podcast is Incremental CI.
Yes.
Also on Instagram.
Yes, it is. We'll talk to you soon.